So today we are going to demonstrate a program for finding the sum of n elements. We are using the two header files 8089x51.h and kjcserial.h. We begin with the main function. We declare the variables in it byte1, n, I, c, sum. Byte1 is for receiving the number from the user, n is for receiving the limit from the user, I is a loop variable, c is for carry, and sum is for keep storing the sum of the numbers entered by the user. We set the timer to mode 2, which is 8-bit auto reload. We set the baud rate to 9600. We set SCON in mode 1, which is 8-bit UART, and also keeping the microcontroller receive enabled. We set TR1 equal to 1, and we begin the loop by while always true. We initialize sum equal to 0 and c equal to 0, and we pass on a message, enter the number of elements, which is enter the limit, like how much numbers are you planning to enter. So that's from the user side, and it's stored into n using the function read by pcof, which is available in the kjcserial.h. And then we enter another for loop in which I is declared as 0. I is the condition is I should be less than n, where n is the limit provided by the user. And on iteration, we get this message: enter the number n times, that is till, for example, if the user has given uh, n is equal to 3, when the value of I becomes 3, the loop terminates, and this loop will run for 3 times, that is I equal to 0, enter the number, I equal to 1, enter the number, I equal to 2, enter the number. When I equal to 3, the condition fails and the loop terminates. So the number is stored from the user is stored in the byte1 using read by pcof, and this byte1 acts as a temporary variable, and the sum stores the sum of the numbers. We have declared in the beginning sum equal to 0. On the first execution, sum will be loaded with the first value entered by the user. In the second execution, the value entered by the user will be stored with byte1, and since sum holds the previous value, that value and the value in the byte1 will get added and will get updated in the sum. And as the execution progresses, the next number also will be added, and the cycle continues unless I is equal to n. And then we are checking this special condition, like on this adding time, if there exists a carry. If there exists a carry, then we are initializing c equal to c plus 1. So what is the necessity of having c? Cy is a volatile value and it changes continuously. Say for example, for this addition, sum equal to sum plus byte1, we have a carry, cy will be 1. For the next condition, say sum equal to sum plus byte1, there exists no carry, then cy will be 0. So cy's value is volatile and it changes as and it's dependent on the sum value, that is sum plus byte1 value. So we are constantly updating the value of cy to a variable called c, and then we exit the if condition, then we exit the for loop, then we come to the while loop, and it's like printf sum, and we first print the carry. If there is carry, then we will have the value which is declared, which is updated in the c, or else c will be 0 as we have initialized in the beginning of the while loop. Then we print the sum using the function by2pc, and this is the programming part. This has been debugged and the hex file has been created. Let's move to the Proteus software for the simulation. So we are using 8089C51 microcontroller and a virtual terminal, in which the connections of virtual terminal, if you observe, can be seen as the THT is connected to RHT and the RHT of microcontroller is connected to THT of virtual terminal for mutual interaction with each other. We have loaded the hex file. So let's run the program. So enter the number of elements. Say the example we took prior, 0 3. So we can enter the number as 0 1 0 2 0 3. So the output is 0 0 6. Let's enter 0 7, 0 1 0 2 0 3 0 4 0 5 0 6 0 7. We get it as 0 0 1c. This 1c is a hexadecimal value. So that's the thing we should be concerned about the program. This, for getting the decimal value, we have to convert this hexadecimal. We have the hexadecimal calculator for that, or else we can do the calculation and find the value. So let's assume a case where we have to enter 10 numbers. So if we are giving the numbers as n as 10, let's count the number of entries we are making. 0 1 0 2, that's entry number 2, entry number 3, entry number 4, entry number 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is the case because the value which we give in decimal is not considered as it is by the microcontroller. It's considered as the hexadecimal value. So what value should be entered to get the sum of 10 elements? Let's enter the value as 0a. Okay, so let's make the entry. First element, second element, third element, fourth element, fifth, sixth, 7, 8, 9, 10. So for getting a 10, for giving the limit as 10, we should be entering the hexadecimal equivalent 0a. Similarly, for any value which you want the limit, we should be entering the hexadecimal equivalent of the value. Say for 11, we should be entering 0b. So that's the programming. Thank you.